Hi, everyone, and welcome. My name is Ricky Chang, and I'm your host for Easy AP Computer Science A tutorial. In this episode, we will learn about expressions and statement, which are the foundations of calculation and action that a program can do. I loved construction toys as a child, Legos, Tinker Toy, etc. I played with them for hours, building things from my imagination. For me, programming is the grown-up version of construction toys. In this episode, we will explore this connection between construction toys and Java programming to help you visualize the elements of Java. I'm an ex-Microsoft software engineer and an ex-Google ML product manager with 30 years of experience in the tech industry. I want to help busy students like yourself to get excited about programming and, of course, get top score in your AP CSA exam. In the last episode, we talked about literals and variables. You already used the assignment operator to put a value into a variable. An assignment is the equal sign. There's the right-hand part, which has the value, and the left-hand part, which must be a variable. Java performs the action to put the value into the memory defined by the variable, similar to algebra when assigning a value to the x variable. A good programming language makes some common instruction easier to read and run quickly. If you need to count a bunch of even numbers from 0 to 100, you need to add 2 every time. Instead of writing counter equal counter plus 2, there is a simpler way in Java by using compound assignment. You can write counter plus equal 2. You can use other arithmetic symbols such as subtraction, multiplication, division, and more for similar results. For example, you can write counter star equal number 2 to double 2, 4, 8, 16, etc. Using the equal sign, taking the left value in the right variable to perform the assignment operation. You also see the plus sign adding two numbers or combining two strings together. Java generalizes pattern called operators. An operator takes 1 to 3 operands, those are the inputs to the operation, then compute a new value. This enables Java a tremendous amount of flexibility to compute new values. There are more than 30 types of operators, as you can see in the gray box in the corner of the slide. So we have many ways to organize operators. One way is by the number of operands used. Java have operators that can take 1, 2, or 3 operands, respectively called unary, binary, and tertiary. The most important unary operators are the post-increment and the post-decrement. You'll see them often because they allow you to do three things with one simple operator. 1, retrieve the value from a variable. 2, add or subtract 1 to that value. Number 3, assign that value back into the variable. This will be used extensively in APCSA. The minus sign is another example of a unary operators. It flips the number from a positive to a negative or vice versa. Binary operator use two operands such as plus and the greater than sign. There's only one tertiary operator in Java, and we'll discuss those in the future episodes. Another way to distinguish the operators is by the type of calculation performed. You are already familiar with a typical arithmetic operator, with the exception of the percent sign. The percent sign is the remainder operator, also sometimes called the modulo. It computes the remainder of the division instead of the quotient. Remember, integer division stops after the unit digits, and it doesn't compute the decimal portions. The remainder operator is useful if you want to check for even or odd, or if the quotient is the whole number multiplier of the divisor. Java is smart about the plus operators. If both operands are numeric, then it would do the arithmetic to add them together. If the operands are both strings or a mixed type, it will know that to use the string join. Cast is the operator you need to convert one numeric value to another. I will cover this in much more detail in the later slides. To help you remember, I use the hammer emoji. Think of the cast in terms of methodology. The original data is hammered and molded into something new. In algebra, you're already familiar with the for greater and smaller comparison and the greater and equal comparison. Equal, equal, and the exclamation mark equal are tests for equality and not equality. In my example, if you test 5 equal equal 5.0, the result will be true. Finally, the logical operators are the double ampersand and the double pipe. These are the logical and the logical or operations. For now, you just need to know that the logical expressions take two Boolean values and then compute another Boolean result. Java is a statically and strongly typed language. It is a fancy way of saying Java knows at all times what the data type of a variable, even when the temporary ones in the middle of the calculations. For each operator, Java checks all the input operands to make sure there is an allowed type pattern. For arithmetic operators, int operands will result in an int, similar for doubles. When the numeric operands don't match, the int will be promoted to a double automatically, then the types will be the same and double will be the result. Conversion is changing the primitive numeric types. In AP CSA, we only need to consider int and double as numeric primitive types. Promotion is done for you automatically by Java as a matter of convenience, when it's safe to do so with no loss of information. Remember, an integer uses 32 bits and a double uses 64 bits to store the value. It can ensure accuracy by going wider using more bits. In my example of converting 1 inch to centimeters, will involve converting 1 to a 1.0, and it's done automatically. You still have to be careful to realize the type has changed. Going from a double to an int is narrowing. Java will give you an error message in this situation. It is up to you to decide to either to change the numeric type or cast the value. Java cannot guess at your intent. In my example, I want to take the Fahrenheit temperature and display the Celsius for weather app. I don't want to show the decimal, so casting here might be okay. Here's the key. Casting drops the decimal portion. It does not round. If the conversion results to 25.9 degrees, the 0.9 will be dropped and the new value is 25. This is done for efficiency reasons. Similarly, converting 1.0 to 1 would not result in any actual information loss. Java could have done this conversion safely. For consistency and efficiency, when there's a risk of information loss due to type change, Java will give you an error and let you make the decision. A quick note about Boolean. In other programming languages, Boolean is sometimes considered a numeric value, similar to a 1 or a 0. Java is strict that the Boolean is not numeric. There is no casting or promotion from Booleans. The magic of operators is that they can be combined in powerful and expressive way. Java gives you many operators and minimal restriction on how you can use them. Let's explore two examples. On the left, there's a simple example of 5 plus 5 times 5. The naive evaluation will give you 50. 5 plus 5 equals 10, then multiply by 5 gives you 50 as a result. However, Java uses the order of precedence. The multiplication, divisions, and remainder operators are done before addition and subtraction in one expression. The result is actually 30. I've drawn the Tinker Toy version of what's happening to show you how Java takes the right operand and the left operand and apply the operator as a result of new operand that can be used to the next operator until up and up it goes and everything is done. On the right-hand side, here's an example where Java will get confused. I want to calculate the circle with a radius of 4. You might recall the area of circle is pi times r squared. Unfortunately, Java doesn't have an exponent operators, so I have to multiply the two numbers together. I only want the whole number portion, so I cast the result to an int. Well, everything looks okay, but Java actually throws an error message for incompatible type. You may be scratching your head wondering why I have a cast operator. Following the Tinker Toy example, you will see that the cast and the promotion happens before the multiplication due to the rules of precedence. The right-hand side of the assignment now is a double. You can see that is a 48.0, and it cannot be assigned to an integer. The fix is to add a parenthesis around the computation portion. Now Java will compute everything inside the parentheses first, then do the cast. You will need to practice and explore how to use and combine operators. This will be more intuitive once you understand all the rules. Here's a table of all the different operators used in AP CSA. The precedents are from the top to the bottom and also from level 1 to level 2. There's an associativity preference for the right or the left. The chart looks a bit complicated at first because it's meant for you to save for future reference. Let's go through the top two examples. First, a plus 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 semicolon. The instruction looks like you want to increment by 2. Java will flag this as an error. The first part of a plus plus is great, but it returns a value, not a variables. The second plus plus operator cannot be applied to a value. In the next more complicated example, where we use unitary minus along with the post increment, setting a to 5 and then printing the result of the expression, a plus plus has the highest precedence. A will return 5, then add 1 and set the value to 6. The unitary minus will convert 5 from a positive number to a negative number. The rest of the expression is to combine the negative 5 in the space. The last A evaluates to 6 due to the increment from before. The end result is negative 5 space 6. I leave the rest of the example for you as exercise. Pause the video and use the chart to practice computational thinking. With more than 30 operators, your imagination is the limit on what you can do. I asked Google's Gemini to generate some extreme example of Java operator combo. To be honest, these operations are mind-boggling, and I didn't take the time to figure out what they actually do or if the Gemini gave the explanation is correct. I think it's great that you can use GenAI tools to help you study. First, as a tutor to explain things, and also as a teaching assistant to generate additional practice examples. As a part of writing this particular episode, I went to the Java language spec in chapter 15. I encourage you, just for grins, to do the same and read the pages and pages and pages of rules on how Java interprets the operators. The main idea is Java is a very powerful language with lots of flexibilities. One of Java's strengths is the guarantee of execution. It will execute the same way, in the same order, and give you the same result every time, even on different machine types. Back when Java was invented, this power was virtually unheard of. Now, it is the reason why it remains one of the most popular languages. However, there's a downside to all this flexibility. Java allows you to shoot yourself in the foot. You should always remember, keep it simple and straightforward, or KISS. It's a great guideline. Whenever you find yourself doing complicated expression, first, break it down and use separate concepts, even if it means writing a couple of extra variables to store the intermediate results. For example, you want to calculate the surface area of a cylinder. Yes, you can write one long algebraic expression to compute everything. However, it's better to compute the end caps and the wrappers separately and then add them together. Frequently use the parentheses to ensure the order that you want is expressed exactly as you meant it. Time to bring all these concepts together and generalize them. You learn variables, literals, operands, and operators. These are the elements and the rules of how you write expressions in Java. Expressions is how Java performs all the various calculations to get one value as the result. Starting with primary expressions, these are the simplest kind of expressions. I like to think of them as the wheels in the Tinker Toy, the ones on the outer edge of this pyramid. From these wheels, you can use operators, the rods, to build compound expressions. Because these operator creates a new value, you can use the result to build even more expressions, and you can just keep stacking them. Expressions are powerful, but a bunch of expression alone would not make a valid Java program. They're like phrases of an incomplete thought. A valid program must have a statement. A statement is like a complete sentence in English. The semicolon indicates the end of the statement. By convention, we use one statement per line, but there is no restriction. One line can have multiple statements separated by semicolons, or a statement can span multiple lines. A statement is valid when some effect is actioned. It could be creating a variable, assigning a value, reading input from the user, or displaying information to the user. A pure calculation is not a statement because there's no effect. There are 4 types of statements. You've seen many examples of declaration and expression statements already. We will cover control flow statements in future episodes. Empty statement is a semicolon by itself. They are useful when paired with control flow statements. A block organizes a sequence of statements. You already seen block as part of the main method in every program. This will run the statement inside the block from top in order Continue until the last statements are done. We'll cover more advanced statements in the future, and then you see why empty blocks are allowed and useful. Just for fun, here is the shortest running Java program. It doesn't do anything. You must have a class with a single letter, a method signature of main with an empty block, all on a single line. This is the last important concept in this episode. Comments are quote-unquote optional. You'll see them throughout coding examples from the AP CSA exam. Java programs ignore these sections because they're not meant for the computers. They are your message to another programmer. And the other programmers is usually your future self. Some professional programmers learn this lesson the hard way. You come back to a piece of code that you wrote a few months back to fix a bug, but you can't remember all the assumptions you made. Now you have to spend hours deciphering your code again. You will need to read the comments provided at the AP exam and know that they're not part of the code, but the message is written for you. There are two types of comments, the end of line and the block comments. The two slash together indicate the start of the end of line comment. Everything after the slashes will be ignored by Java until the start of the next line. There are two common usages for the end of line comment. The first usage is to describe the thinking behind this line or this small section. Usage 2 is to disable the section of the code across multiple lines. The other type of comments is the block comments. When you use the slash star, and then you can write all your comments as many lines as you need until it sees the star slash. That will indicate the end of the block. And everything inside the block is ignored by Java. Block comments are often used on top of class, files, and method in other major sections of the code to describe its purpose. The key thing to remember about comments is to explain why. A good code will already explain the what and the how. Comments provide the extra context of why you wrote this code and the assumptions you made at the time. Let's apply all the concepts we discussed so far. You can better understand the different section of a Java program. Here, you have a class with a block. Then the main method signature with another block. This block represents the set of code that Java will execute for its effects, starting with the declaration statement to create variables and allocate spaces for them. And then you have expression statements. These are complete statements that are both an expression and a statement. In AP exam, you will see ... These are called ellipses. This is a way to indicate that there are more code, but not displayed because they're not relevant to the exam questions. Congratulations. We have reached the end of the episode. Now it's time to put all these concepts together and practice. You should pause the video and type the bit.ly URL. You'll land on this page. Copy the two code parts in your editor, one after the other. You should look for the end of the line comment with a double question mark and replace them with the expected value. Then I want to set a breakpoint and run the debugger. Step over each line to see if you get the correct results. Your program should look something like this. Let's hit debug. See all the variables are initialized, and you're on the line with your first breakpoint, and we're going to do a step over. I'm expecting to get 30, and the output is 30. Great. Step over each one as you intended. Think about whether you get the value correct or not. For additional practice, you can use GenAI to help you generate more examples. Let me demo it for you. I'm going to remove all these existing statements, and I'm going to start a chat by, I have an existing prompt, but you can practice to generate your own. So here's my prompt. Write some code to test my knowledge of cast, operators, and precedence and associativities using integer and booleans and doubles only. Do not use postfix increment inside the expression. Do not provide the answer as part of the comment. I'm going to upload this prompt. It will generate a set of code. And you can take each individual section and say, review it and accept it if you want. I'm going to go ahead and accept them all. Okay. The key things about this is you don't have to worry about AI hallucinating. It's generating a code. And the point of this is just to practice to computational thinking. And the result that you get is your understanding whether the code is correct or not. So even if the Java generates some weird code, as long as it compiles and runs, that's great. If it doesn't run, delete that portion and move on. Writing a program is a bit like writing an essay. There are grammar rules about how you can put words and punctuation together in a sentence. 3 to 5 sentences make a paragraph. Each sentence must be complete with subject, verbs, etc. Unlike writing, programming has rigid rules to ensure correctness, consistency, and performance such that a computer can follow your instructions precisely. In this episode, you have learned all the elements you need to write endless variety of simple programs, converting Celsius to Fahrenheit, estimating how much tip to give, and many more. The best way to get better at writing is to write. Same for programming. Keep practicing writing new programs. I look forward to building more programs with you. You have learned everything you need to write simple programs, but you don't have to write everything from scratch. Java has a vast library of code that has already been written. In the next episode, we will learn how to access and use them. Please like, subscribe, and most importantly, give us the gift of your feedback in the comment section below. Your feedback and encouragement will help this community grow and better serve other busy students like yourself. Thank you for listening.